Hello students. So we were studying about the Biot Savarts law and its application. So now we will solve some numerical based on the Biot Savarts law. So our first numerical is a wire carries a current of 3 ampere and consists of circular arc of radius 5 centimeter and central angle pi by 2 radian. Mean to say that one circular arc subtend angle of pi by 2 at the center and two straight sections intersect at the center of the arc when produced. So find the magnetic field at the center of the arc. So in the given numerical, we are given that there is one arc. We have this much arc that is given, and this arc will subtend angle. This is the center of this arc, and subtend angle pi by 2. Okay, and having two straight sections intersect at the center. So these are the two straight sections intersect at the center when produced. Okay, so and current of 3 ampere is flowing through this wire. So now wire is divided into 3 parts. First arc, and second is straight section at right side, and one more straight section at left side. First, second and third, these are the 3 parts of this wire. So we know that now you see these first and third part, these, the point of observation that is lies just on the axis of these 3 straight sections. So we know that magnetic field on the axis of straight conductor is 0. So we can write magnetic field at center due to straight sections is 0. Due to these two straight sections, magnetic field is 0. Now magnetic field due to arc at center is, so we know the formula B is equal to mu naught upon 4 pi and I upon, this is the radius, I upon R into angle subtended. This formula we already know. So mu naught upon 4 pi, you know that 10 raised to power minus 7. The value of the current is 3 ampere and radius is given 5 centimeter, 5 into 10 raised to power minus 2, because radius is in a centimeter, and angle is pi by 2. This angle is pi by 2. So by solving this value we get 3 by 5 into 10 raised to power minus 5, 3.14 divided by 2, and by solving this we will get the answer 9.426 into 10 raised to power minus 6 Tesla. This is the magnetic field at point O, or at the center, and the direction of this magnetic field. Direction of magnetic field is inward into the plane of paper by using light and thumb rule in vector form. So this is the current. In this way we can find out a thumb will in the downward direction. So curling can give the direction of current. So thumb in downward direction. So this is the numerical. So thank you. So let us have next numerical. A long horizontal conductor is bent as shown in the figure and carrying current I. Find the magnitude and direction of magnetic field at the center of the circular part. So we have this type of conductor having two type of the portion in the conductor. So one is the straight part A, B, D, E. This is the straight part of the conductor A, B, D, E, and second part is a circular part, that is B, C, D. So due to these two parts of the conductor, we have to find magnetic field at the center of this circular part. So magnetic field at O due to straight part of conductor is B is equal to mu naught upon 4 pi 2I upon R. You have to remember, here I am not writing 2 pi I. Here I am writing 2I upon R. This you have to remember. This is the magnetic field due to the straight part of the conductor. That part is not in our syllabus, but we have to solve the numericals, and in this numerical we have to use the concept of magnetic field due to straight part of the conductor. So this formula you have to remember. Here we are not writing with here pi. When we have a circular part, then we write here pi, but in straight conductor the result of magnetic field is mu naught upon 4 pi 2I upon R, and the direction is, so by using this rule, the observation point is upward direction, thumb is in upward direction. So we can find direction upward by using a right hand thumb rule in vector form. Okay, so this is our equation number 1. So similarly, magnetic field due to circular part of conductor is B is equal to mu naught upon 4 pi 2 pi I upon R. Due to this part, which part, that is B, C, D part, and this is due to A, B, D, E part. So this magnetic field is inward. This is 2. This is B1 and this is B2. So net magnetic field, we can write this is a outward magnetic field and this is a inward magnetic field. So if we will take inward magnetic field with negative sign, outward magnetic field positive sign, so B1 minus B2, and that is equal to mu naught upon 4 pi and 2I upon R, that is common, and we left with 1 minus pi, and the direction of net magnetic field, that is so pi, that is equal to greater value minus say this value will be in negative, so that is net magnetic field is inward direction. So this is the solution. Thank you. So have next numerical. Determine magnetic field at O due to the current I through the circuit as shown in the figure. So we have this type of the circuit A, B, C, D, where here we have AD and BC. These are the two arcs, and AB and CD, that is straight part, and these two arc AD and CD having the radius R1 and R2, and at this O point we have to find out the magnetic field, and these two arcs subtend angle theta at the center. So solution is, so magnetic field due to arc AD at O is mu naught upon 4 pi I upon R1 into theta, and this magnetic field is upward. Magnetic field is upward, and magnetic field due to arc BC at O is B1 B2, that is equal to mu naught upon 4 pi I upon R2 into theta. Radius is R2, and that is inward. Okay, next is magnetic field due to straight parts, that is AB and CD is 0 because O lies on the axis of straight conductors or straight parts. So net magnetic field, so this magnetic field also 0. So net magnetic field, this is upward, this is inward. We will write B1 minus B2, that is equal to mu naught upon 4 pi I theta 1 upon R1 minus 1 upon R2. So this is the net magnetic field, and the net magnetic field is upward लिख ली, इसको डाउनवर्ड भी लिख सकते हैं. Now our next numerical is an element dl, that is equal to dxi. So dx is the magnitude and I is the direction, so that is along x-axis, where dx is equal to 1 cm is placed at origin and carries a large current of 10 ampere. So what is the magnetic field on the y-axis at a distance of 0.5 meter? So firstly you understand what is given and make the diagram, and so this is our x-axis, this is our origin, and this you take y-axis. So element is placed along x-axis, this much length of element is placed along x-axis, that is of dl, this is dl, and the current I, you know that the current will flow in the direction of the element, so this is the direction of the current along x-axis. So this is our current element, and at a distance of 0.5 meter, suppose at point this P point at 0.5 meter distance along y-axis, we have to find out the direction of magnetic field. So I think this is clear. So here dl vector, that is equal to dxi, and dx is given to you 1 centimeter, that is equal to 10 raised to power minus 2 meter along x-axis, and the r distance, that is equal given to 0.5 meter. Now because b is equal to mu naught upon 4 pi I dl वेक्टर फॉर्म में दे रखा है, तो वेक्टर फॉर्म में इसको यूज करेंगे. So here r cube, so here we will write mu naught upon 4 pi I dl, and dl, that is equal to, here I will write mu naught upon 4 pi I, and dl is given you dxi, and r, that is along y axis, that I will write r, and along y axis, because r is along y axis, so we will take here r into j vector and r cube. Further we can write mu naught upon 4 pi I dx r I cross j vector divided by r cube. So we will simplify this. Mu naught upon 4 by 10 raised to power minus 7, 10 dx 10 raised to power minus 2, r that is equal to 0.5 I cross j and divided by r that is equal to 0.5 and cube. So that we will solve and we'll get 4 into 10 raised to power 8 and I cross j that is equal to along k. So magnetic field is along z axis. So I hope this is clear to all of you. Thank you.